Okay, so welcome. This is our third week. I assigned 4 problems a week ago, and I received 41 submissions. Among these 41, I think 14 of you had all 3 questions answered correctly. Congratulations. This is a great job. Actually, for this specific assignment, the elementary school students did a better job than the middle schoolers. Okay, I think that only 2 middle schoolers did all questions correctly, but I think 11 out of 30 elementary school students get it right. So the correction, perfect score rate for the elementary school students is more than 30%. Okay, good job. Good job, young kids. Okay. Today we're going to talk about the 4 problems here. Okay, I'm highlighting them here. These are the 4 problems we're going to discuss today. Some of them are easier, some are more difficult. As always, I'd like to challenge you to think about multiple ways or alternative ways of solving a problem. Okay, so let's start with problem number 1. Oh, by the way, before we start, let me first recognize our spotlight student. Okay, is Q here?
Yes.
Yeah, please unmute yourself. Oh, good. So Q, you're the spotlight student today. Can you briefly introduce yourself? Who you are. Your grade, your school, and your favorite things about math. Please spend no more than 2-3 minutes to talk about yourself. Okay, since you're the spotlight student.
My name is Katie. I'm in 5th grade and I go to Elon Park Elementary. And I don't really know why I like math. It's just fun. Because one time when my brother was learning multiplication, I also wanted to learn, so then I learned, and then I just got really interested in math.
Very good, very good. So you did a wonderful job this week. You're the number. You not only got all the questions correctly, you also had them answer you are the fastest one to answer these questions. Okay. So I will assign you one of the problems to talk about. There are totally 4 problems. I will let you talk about one of them. I think. Let me see. I think I plan to have you talk about problem number 4. Okay. That's probably the most difficult one. I'd like to give you that problem to talk about later on. Okay. So now please mute yourself. Okay, everyone, please mute yourself. Good. Let's move on to our problem number 1. Please mute yourself. I think some of you didn't mute. Andy, please mute yourself. Okay. All right, let's get started. Okay. As always, I'm copying the problem here. The fraction 360 divided by n is the simplest form. In the simplest form, is a whole number. So n is a positive integer. What is the total number of different values that n can be? So this is asking us to find n. Okay. The person who answered this question the fastest is Rakhav Arun. So let me see if Rakhav is on the call.
I am.
Okay, so I will let you introduce your method after I talk about a general method. Okay, so please be prepared. All right. For now, please mute yourself. So let me first talk about talk about my way. All right. So this is again, I will give you probably a more trivial way, but probably take longer time. Then I want to see if you guys have better ways to solve this problem. Okay. So let's say since it's asking us to count how many number of different values n can. So let's just count, okay? So it says 360 divided by n, okay? We'll just count, you know, what values n can be? N can be 1, right? N can be 1. If n is 1, the result is a whole number, which is 360. So both 1 and 360 work, right? So we'll just keep counting. So n, the next one will be 2. So if n is 2, the whole number is 180. So that means n can also be 180. So they all come in pairs. So what about n is 3? Then we'll get 120. N is 4, we got 90. N is 5, we got 72. N is 6, we got 60. 7 doesn't work. 8 works. 8, we got 45. 9, we got 40. 10, 36. Again, all these come in pairs, okay? 11 doesn't work. 12, 30. 13 doesn't work. 14 doesn't work. 15 may work. 15, 24, is that correct? Yeah, 15, 24. 16 doesn't work. 17 doesn't work. 17 is a prime. 18 doesn't work either. 19 doesn't work. 20 works. Oh, 18 works. 18 works. 18, 20. And then 19 doesn't work. Then the next one will be 20, but then you have 18, so it's redundant. So get rid of it. Let's count how many of these are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In total, we have 12 by 2. We don't need these two. In total, the answer is 24, okay? So some of you made mistakes. You didn't count 1 and 360, okay? You didn't count these two. So some of you got 22, so you're very close. But the answer is 24, okay? So now I want to hear from our fastest kid who answered this one correctly. Please, Rakav, can you unmute yourself and see if you have other ways to do this?
What I did was I just wrote the numbers that were factors like from 1 through 18.
Mm-hmm.
And then I just multiplied that by 2 because I knew that 20 was 19 didn't work, and then 20 was the next one, which is 20 times 18. We'll get 360.
Mm-hmm.
And then I found that 1 through 18 is 12 times 2 is 24. That's basically what I did.
Okay, so yours is, I guess, similar to what I'm showing up here?
Yes.
Okay, so then I will open the floor. There are the other students who did this, in a different way, but faster. There are other ways to solve this problem?
I just did
can you introduce yourself first?
What?
Yeah, is that David?
Yes.
Yeah, can you say who you are and where, which grade and which school? And then
Okay, I'm David. I'm in 7th grade. I'm going to Marvin Ridge Middle. Okay, so I just found the factors, the prime factors of 360. I found that it's 2 cubed times 3 squared times 5 to the first. And then the way you find number of factors is you take the exponents of each factor and you add them by 1 and you multiply together. So it will be 3 plus 1 times 2 times 2 plus 1 times 1 plus 1. So you get 24 from that.
Good job. All right. So this is probably the easiest way to solve this problem. I mean, there may be others, but this is the easiest one I know of. So what you do is you do prime factorization of 360, okay? Whatever number the problem was asking. So 360 is what's being asked here. So 360, you do prime factorization. You'll find there are 3 2s and 2 3s and 1 5s. Okay, 5 is basically 5 to the power of 1. Then if you want to figure out how many factors 360 have, it basically had, look, you have 3 2s. So that means you can, for the prime factor 2, you can put 0, 1, 2, or 3 2s. So you have 4 ways of adding 2s, right? 4 ways of adding 2s. And then for the second prime factor is 3 to the second power. So you can put 0 3s, 1 3s, 2 or 2 3s. So you have 3 ways of putting 3s. For 5, it's 5 to the first power, so we have 0 5s or 1 5. So in total, it's 4 times 3 times 2 equals 24, okay? So you may be wondering, so why can we do this, right? So look, if we put 0 2s and 0 3s and 0 5s, what do we get? We got 2 to the 0's power times 3 to the 0's power times 5 to the 0's power. That's 1 times 1 times 1 equals 1. So that is one of the factors of 360, okay? Again, you can do, 0 2s and 1 3 and 1 5. So you got 2 to the 0's power times 3 times 5, you got 15. That's another factor of 360, okay? So this is, I think that's probably the easiest way to solve this problem, okay? In the future, if the number is even bigger, you can use this, if it's hard to count, you can use this way, look at the exponents of these prime factors and figure out the total, okay? So let's move on to the next one. Good job, Dave.
Thank you.
All right. So the next problem, well, the next problem is about Leo, okay? Leo is my son. He's in the meetup as well. So for some of the problem you see name Leo, that's Leo, okay? So Leo is writing a diary, and this is true. He is writing a diary, and he's going to publish it. So the pages of his diary book are numbered consecutively starting from 1, and the digit is printed 44, the digit 4 is printed 44 times on page numbers. So that means if you have page numbers, say 1, 2, 3, 4, all the way to 10, how many times 4 was printed here? 1 time, okay? But then this problem said digit 4 is printed 44 times on page numbers. Then this, I was asking, what's the minimum number of pages his diary book can have, okay? As always, I will talk about my approach first. And the person I'm trying to assign to this problem, I decided to pick a girl, Summer 2. Is Summer on the call? Okay, Summer is not, I guess. How about, well, then the girl is not on the call. Chauncey, is Chauncey on the call? Okay.
Yeah, I'm here.
Oh, Chauncey there? Okay. Can you be prepared to talk about this after I introduce my method?
Okay.
Yeah. For now, please mute yourself. All right. So both Summer and Chauncey did it in 2 minutes. I mean, there are other kids who did it in 2 minutes, but they didn't get all four problems correct. So I'm picking the ones that answer all 4 correctly, and then that are fastest on this specific problem. Okay. So let me first do accounting. Okay. So again, my way is not the easiest way. So this first method is not, the first approach is not the easiest one, but let's just go with it. Let's see how it goes, right? So I just did from 1 to 10, 4 show up once, right? And then I can do from 11 to 20, all right? 4 will show up once as well. If I do all these all the way to 91 to 100, so this is from 111 all the way to 99, there are 10 groups, okay? 10 groups. 10 groups. 4 will show up 10 times on the unit digit. The exception is 40. If we go from 41 to 50, okay? So 4 show up here 9 times in this group, 49. And then there's another 40 here, 4 show up here in the 10th digit. So it should be 4 times 10 plus 10. So in total, there are 50 times, right? So if I'm just counting 4s, it goes from 1 to 100. 4 show up 50 times, right? So it says that, hold on.
Oh, 20.
Sorry,
It shows up 20 times.
not 4 times 10. So the first one is, 4 show up on the unit digit 10 times, and then show up on the 10th digit 10 times. So it should be 20, okay, 20 times. And then it said the digit 4 is printed 44 times on page numbers. So now I have 1 to 100, right? If I do the same for 101 all the way to 200, 4 will show up another 20 times, right? Because 100th digit, there's no 4. So the 10th digit and 1st digit is the same as from 1 to 100. So 20 times, okay? And then 20 plus 20, this is 40. So all I need is to find another 4s. So let's see, from 200, 201 all the way to 210. This is there's 1 4, okay? And then 211 to 220, another 4. 221 to 230, another 4. The fourth one, 231 all the way to 234, this is the next time 4 show up. It's another one. So the minimum number of pages, 234, okay? So this is just counting, right? So if you don't know any other way, just do a counting. Pick a group and count, right? So this is one way to solve this. And then I want to hear from Chelsea. Can you talk about, well, first introduce yourself and then briefly introduce your method.
So my name is Chauncey. I am a 4th grader at Valentine Elementary School. So I actually got the answer pretty much the same way as you did.
Okay,
Funny.
so do you group the same way from 1 to 100 and
Yeah, like I just grouped them, and I also made sure that I counted 44 as 2 4s, not only 1.
Okay.
Yeah.
Okay, so well, since Chelsea did the same way, I guess
Yeah,
you're
pretty much.
a quick counter. Okay, so any other ways?
Yeah, I'm quick at it. I'm quick at counting.
Yeah, good, Chelsea. Any other method? So Chelsea, please mute yourself. Whoever had a different method, please unmute yourself and then talk about it. Okay, so if there's no other method, I mean, let me just give you a slightly different way of counting this. Okay, a slightly different way of counting this. So let's all start from the unit digits, because we know all these numbers say 14, right? 24, all the way to 94. Of course, 44 is part of it. Okay, all of them had 4s. Okay, unit digit 4s, and we know within 100 we have 10 4s, right? And 10 of the 4s on the unit digits, and we'll just count unit digits. In total, we want 44 times. 44 times. Okay, 44 times. If we just count unit digits from 1 to 90, and then 104, it basically, instead of 9, it's basically a 10 before it. And then all the way, we can just go through 204, all these. But then we also need to keep in mind when every time we meet 40 to 49, there are 10 4s on the 10th digit. Okay, there are 10 4s on the 10th digit. So if we do this counting, so from 14, and then first of all, the first one was 0 4. Okay, from 0 4 to 34. Well, 34. So these ones is only unit digit 4s. So this is 4, and then we can do 41 to 49. So there are 10 of these 4s. Okay, and then we keep, this is basically separating these 4s with unit digit only and the ones with unit digit and 10th digit. Okay, so this is 10 of these 4s. 40 to 49, sorry, 40 to 49, 11 4s, because 10 of them on 10th digit and 1 on a unit digit. And then 50 to 134, okay? 50 to 134, there are 9 of these, right? So from 5 to 13, 13 minus 5 plus 1, 9 of these. And then 140 to 149, there's another 11 of these, okay? And then 150 to 234, another 9 of these. You see 11, 9, 11, 9, right? So this is 20, this is 20, this is 4. In total, 44. So that's how I got 234. Again, just a different way of counting. This may not be easier, but this is basically segments the 40 sums, or 140 sums. Use these 4s on 10th digit to segment the sequence. Okay. So let's move on to the next question. I want to take a quick look at the chat box. Hey guys, I told you last time, please don't spam the chat box. Okay. I didn't ask you to type in the chat box, so then don't type. Okay. Please focus on the lecture. All right. Next problem. Next problem is probably the easiest. Actually, most of you did the next problem correctly. So I will go over it rather quickly, okay? So I'm trying to group the students in this meetup, okay? I'm trying to group the students in this meetup. If I form a group of 2, then 1 student is left out. If I form a group of 3, 1 student is left out. If I form a group of 4, 1 student left out. If I form a group of 5, still 1 student left out. Then I ask you, what if I form a group of 6? Okay, how many students will be left out? What if I form a group of 6? Okay. So, you know, since most of you did this question correctly, so I will basically introduce 2 methods, you know, to solve this. Let's probably cover most of your methods. Okay. Hey, there are 2 students right there still spamming the box. If you keep doing this, you're not going to be invited next time. Okay. So first of all, let's see. You know, one way. You know, first again, the less easier way to do this. We can figure out what this number is. How many students are in this group? Okay. So if let's say it's a number x. Okay. If x divided by 2 is a number remainder 1. If x divided by 3 is a number remainder 1. X divided by 4 is a number remainder 1. X divided by 5 is a number remainder 1. Okay, so these are the known conditions. So since all these remainders are the same, so all we need is just to find the least common multiple of 2, 3, 4, 5, which is 60. Okay, that means x divided by 60 is a number remainder 1. Okay, so this could be x divided by 60 could be 1 remainder 1, 2 remainder 1, 3 remainder 1, doesn't matter. So let's say if it's 1 remainder 1, then there are 61 students. If it's 2 remainder 1, there are 121 students. 3 remainder 1, there are 181 students. So it doesn't matter how many students are there, no matter how big the group is. If I form a group of 6, these numbers divided by 6, they will have the same remainder. They will have the same remainder. The remainder will be 1. Okay. So this is one way to solve this. Okay. Some of you put the answer 61, but 61 is not the only answer to the number of students in the group, because I didn't ask you what's the smallest amount of students in this group. Okay. So this is one way to solve it. But there's a faster way to solve this problem. Okay. Okay, Leo, you want to talk about the faster way?
Well, if he has a remainder 1 when he has a remainder 1 for every single for 2 and 3, and 2 multiplied by 3 is a multiple of 6, so it will also be a remainder 1 when it's divided by 6.
Ah, okay. So Leo said, since I already said, you know, if I divide a group, you know, if I form the group of 2, it's remainder 1. Form group of 3, it's remainder 1. No matter how many other ways to form the group, I don't really care, right? As long as, you know, you form the other, as long as they divide, you know, this number divided by 2 with remainder 1 divided by 3 remainder 1, then they divide by 6, it will be always remainder 1. So actually the other 2 conditions, these 2 conditions, they are redundant. You don't need these 2 conditions. All you need is the first 2 conditions, and then you can get remainder. Okay? All right. So then let's move on to the last problem, which is, I guess, the most difficult one. And I want to invite our spotlight student. Okay. So who is our spotlight student again? Please unmute yourself.
Okay.
Yeah. Akil, please talk about your way of solving.
So
Hold on, Ningping or someone, Ningping, please mute yourself.
I solved this. I wrote down the equation A B C minus C B A
Uh-huh.
It says C is smaller than A. You would need to carry over from B. So B would be so the B on the B in ABC would become one smaller than the B in CBA. So then you need
Sorry, did you mean to write the equation the way I'm writing here, or did you mean to do it like this way?
I wrote it up and down.
Okay, up and down like this.
Yeah.
Okay, good. Okay, keep going.
So since you have to carry over from A to B, once you do that, the B in ABC will be 9 greater than the B in CBA. So the middle digit would be 9.
Okay, middle digit will be 9. Okay, let me elaborate this again. Let's B minus B will give away 10 to C, so C will be 10 plus C minus A equal to something. So then B will borrow 10 from A. Okay, regroup, right? Borrow 10 from A, so then there'll be 10 plus B minus 1 minus B is 9. So the middle digit of this original number must be 9. Okay, so now you get this 9. What else?
And I wrote expressions to show the new values of the A and C and ABC. So I wrote A minus 1 for A and C plus 10 for C. And
okay, so this will be C plus 10 because C borrowed 10 from B, and this will be A minus 1 because A gave away 10 to B. Okay, yeah.
And since 9 is the greatest digit from 0 through 9, that would mean, and A is the biggest digit from ABC, A would have to be 9.
Right, so 9 is the biggest digit from 0 to 9, so A must be 9, okay? So A must be 9. So you got to figure out these A's. You already got A settled, okay? Okay, keep going.
So, and then I wrote that because you carried over 1 from the A and ABC, that would now be 8.
So you carry over from 1 to ABC and then what?
So the A from ABC would we would know that the A from ABC has to be 8 because it's A
Right.
minus 1, which is
Right.
9
So
minus
this
1.
has to be 8, okay? 8 minus C.
Yeah. And then from there, I thought about like, is it possible to have 10 plus another number minus 9 be equal to the so I was thinking about if there was a value for C that when you added 10 to it and subtracted 9 from that would give you C again. But when I did that, there was no number. So that would mean that A minus C has to equal C. And so that would mean 8 minus 4 has to equal 4.
Good job. So you said A, this one, 8 minus C had to equal C. So this has to be a C, right? So then since A gave away 1 to B, so the 8 minus C equal to C, so C has to be equal to 4, right? Then how about this? What's the last number here? So C is 4, C is 4. Then
Yeah.
I guess 14 minus 9 is 5, so the last one is 5, right? Good?
Yeah.
All right. So let me introduce another way of solving this. Good job. Good job, Akil. Right? Let me introduce you another way of solving this. Okay. If you look at ABC, what is ABC really? So ABC is really 100A plus 10B plus C, right? And how about CBA? CBA is really 100C plus 10B plus 8, right? So I say ABC minus CBA is the original 3-digit number. So I don't know the original 3-digit number, maybe CAB, maybe some other ones. But if I just do a minus here, okay, this will be 100A minus A will be 99A. 10B minus 10B they'll cancel out, right? C minus 100C minus 99C, right? So this is saying, okay, that number is 99 times A minus C is the original number, right? Come on, please, please mute yourself, okay? There's some background noise there. So this original number is 99 times A minus C. What this is telling me is the original number have to be a multiple of 99, right? The original number has to be a multiple of 99. So what's that number? Okay, let's try. I mean, 99. So do 99 times 1, 99 times 2, all the way, keep trying. 99 times 9. Well, first of all, yeah, A minus C could be 9. Oh, no, cannot be 9 because C is on 100 digits. C cannot be 0. So all you need is to try through 8. Okay, right, through 8. So when you try these, when you get 99 times 5, you get 495. This number satisfies the condition. Okay, because you know once you have this 99 there, you know this original number is a multiple of 99. And then you can do some enumeration, because this is another way of solving this problem. This is solving it using algebra. Okay. Any questions or comments? We have 1 more minute, so I'll just give you free time to talk about it, talk about anything you want, and then the meeting will adjourn in a few minutes. Okay, so now the lecture is over. If you want to drop out, you drop out, but you can open your mic and unmute yourself and just talk. Okay.